All right, so in the last video that you watched, we figured out missing sides in a triangle get based on angles that are given to us. But sometimes we don't know what the angles are and we know the sides. So how do we find missing angles given sides of a right triangle? Now, before we do that, we have to figure out how do we even solve equations that look like questions 1, 2, and 3. Now, you need to remember that this is function notation. So this is not saying right here cosine times x. It's saying cosine of x. So let's draw a picture of what this is really saying. All right. So we have a right triangle. All right. Let's go back to the marker. There we go. We have a right triangle. And we have some angle x, because remember, when you find the cosine of something, it's always of an angle. And the ratio is 3/5. Remember, cosine is adjacent over hypotenuse, which means that this side would be 3 and this side would be 5. Now the question is, what angle will make this side 3 and this side 5? Now, again, this is not multiplication, so I don't get rid of the cosine by just dividing by cosine, because then I wouldn't know what it would be, cosine of what. So here is how you get rid of this cosine right here and get the x by itself. What you're going to do is you're going to say x is equal to inverse cosine, and this is the notation of it, of 3/5. So basically what this is saying is I want to find out what angle has a ratio where the adjacent over the hypotenuse will be 3/5. Okay, so how on earth do I do that? Well, what you need to do is you need to click in your calculator on this trig button right here, and when you click on it, you will see 12 buttons, and the one that you want is the in the second row, and it's the second button on the left. So you'll see cosine -1. And then you'll have parentheses. And all you have to do is literally type in 3 divided by 5, and then you'll get your answer. And I believe it asks you to round to the nearest degree, which means that x is approximately 53 degrees. So what I want you to do right now, after you've done that, is see if you can figure out the proper way to write out the answers for numbers 2 and 3. This step is crucial. You must show this step. And then see if you get the same answers as me. So go ahead, press pause, try 2 and 3, and then come back to me to see how you did. All right, in number 2, your work should look like this. X equals inverse sine of 0.5. And you should end up getting x is approximately equal to, or actually not approximately equal to, x is exactly equal to 30 degrees. Okay? And then lastly, right here, you should say x is equal to inverse tangent of 4/3. And you should end up getting x is approximately equal to 53 degrees. No, it's not a coincidence that 1 and 3 have the same angle. They're actually from the same triangle, but we can get more in depth with that later on in the future. Okay, so hopefully you understand that. Now how do we apply it? In questions 4 through 7, solve round to the nearest whole number. So let's go ahead and do this. Let's attack this. So I want to figure out what angle x is. What is the missing angle? So I know that I've got 15 and I've got 20, and it's even labeled for you, the opposite and the adjacent. And don't forget, the ratio that's opposite over adjacent is tangent. So if I were to set this up, listen carefully, watch carefully, because you must show your workout step by step, line by line, how I'm showing you right here. So since I'm going to use tangent, I'm going to say tangent of the angle, which is unknown. So I'm going to say tangent of x is equal to the opposite, which is 15, over the adjacent, which is 20. Okay, now I can go ahead and show my workout like we showed earlier. So x equals inverse tangent of 15 over 20. Plug that right into your calculator. You'll end up getting that x is approximately 37 degrees. So if you notice, you use inverse tangent, inverse sine, inverse cosine, all the inverse trigonometric ratios when you're trying to figure out how big an angle is. You use sine, cosine, tangent when you know an angle and you're trying to figure out a side. That's crucial, okay? So let's look at number 5. We're going to read it and do exactly what it says. A piece of lumber leans against a wall. So here's my piece of lumber, here's my wall, and then I'm going to connect the last part of my triangle. The top of this 40-foot piece of lumber, so if this is my piece of lumber right here, then this is going to be labeled as 40, touches a point on the wall that is 36 feet above the ground. So this right here is 36 because it touches it all the way up here. Find to the nearest degree the measure of the angle that the lumber makes with the wall. So right now what I'm going to do is I'm going to try to figure out what this angle right here is, because this is the angle where the lumber and the wall meet, and that's what it's asking you to figure out. Okay, so I'm going to label my information. This is the adjacent. Okay, here's my right angle. This is the hypotenuse. So what I'm going to do is I'm going to say cosine of x is equal to 36 over 40. Now to get the x by itself, I have to say x equals inverse cosine of 36 over 40, which is approximately equal to, go ahead and take out your calculator, type it in. I'll do the same, 36, inverse cosine of 36 over 40. You should end up getting approximately equal to 26 degrees. Okay? All right. Number 6, in the accompanying diagram of right triangle ABC, AB equals 4, BC equals 9. What is the measure of angle A to the nearest degree? So I want to figure out how big this angle right here is. Okay, so I know that this is the opposite and this is the adjacent. So I know all I need to do is use tangent. All right, so I'm going to say that the tangent of angle X is equal to 9 over 4. So that means that X is equal to inverse tangent of 9 over 4, which means that X is approximately equal to, plug it into your calculator, 66 degrees. Okay, and then the last question, number 7. Remember, if I'm going too fast for you, pause, rewind, do what you need to do to really be honest with yourself and make sure you understand what's going on. All right, now number 7 is different than numbers 4, 5, and 6. Take a look at it, see if you can figure out what's different. Press pause if you need a few minutes to figure out what is different. Come back to me, give yourself a chance to figure it out yourself. Okay, what's different about question number 7 is I know the angle. So I'm not trying to find the angle, okay? In 4, 5, and 6, the missing piece of information was the angle. So what I need to do right here is label in my information. I know that X is the adjacent, and I know that 15 is the hypotenuse, okay? Which means that I'm going to have to use cosine. So I'm going to use cosine of 34 degrees, because again, it's always cosine of the angle, and this time I actually know the angle, is equal to X over 15. So this is what we learned back in topic C. It's just a review of it so you don't get it mixed up with what we learned in topic D, okay? To get the X by itself, I multiply both sides by 15, so I get 15 cosine of 34 equals X. Type this into your calculator right here. Don't forget to have your parentheses. X is approximately equal to 12.436 rounded to the nearest hundredth. All right, and hopefully that makes sense to you.